Okay, hi everyone. I'm Silvio Simani from the Department of Engineering of the University of Ferrara, and for this year I prepared this course, which is entitled Intelligent Supervisory Systems. So the idea is to present some solutions, techniques, strategies which are intended to, as the title of the course, provide intelligent first. So with the word intelligent, I at least think to use some algorithm, let's say, because we will see that at the end of everything we design an algorithm, so something which is run on the computer that is able to, in an automatic way, to learn how to behave. So this is the idea of an intelligent, of course. There are, if you are in the machine learning framework, when you define something that needs to learn, a machine especially, you need to define some specific functions, very some initial conditions, so in a more rigorous way, and we will see it when we will examine this part of the course. And so this is the intelligence. So with this idea, which is mainly based on data, so this system is able to learn from the data first. And supervisory is something which is includes different tasks which are different from simple monitoring. So normally monitoring means is a task that is intended to, let's say, check the system and very simply indicate if something is not working properly. With the term supervisory, supervisory is derived from the term supervision in the literature. It was this term was specifically defined about 40 years ago with the idea of something or a system which is able to not only monitor this plant, but also take some counteractions in order to prevent, some the effect of some external forces, so external actions. So it's really something more general than the control. So something that can try, as we will see, to compensate for the effect of a disturbance or a non-input. Normally, the disturbance is something that you cannot measure, you cannot predict, can be stochastic, so it's something that you can't expect. So it's totally unexpected. And also the behavior we will see can be recurrent or abrupt, can be slowly developing, something that develops very slowly with some dynamics. This is the idea. And of course, I provided also, so I noticed that you registered for this course. So the concepts are quite general, so we don't have any specific requirement. So normally I assume that you have a basic basic background on basic mathematics, knowledge of physics, knowledge of dynamic systems, the behavior, input-output or something in the state-space concepts, a limited knowledge of frequency tools. We are not working in the frequency framework, but in some cases can be useful. Also, I assume that you are able to analyze or to perform simple simulations. Also, I included in this last point of course, I'm using the MATLAB and the Simulink environments. Of course, I also included some links here to online courses, mainly because perhaps you can be from a different framework, so it's very easy to attend. It's a limited number of hours. It's self-paced, so it means that you decide independently, depending also on your engagements, the time you are able to live to these courses in order to understand the basic concepts in general, if you are not already familiar with these tools. So the main goals of this course are, as already mentioned, the course is oriented to intelligence. So as I already mentioned, it is something that is data-driven and model-free. So we are assuming that we don't have any a priori knowledge of the mathematical model, or if required, you can use a data-driven, as we will see from the beginning of this course, using simple data-driven methodologies. You can derive a mathematical formulation of your system. And after that, let's say it will take about maybe less than half of the course, we move to to examine some techniques for the behavior, let's say to the design of something that is recasted into this supervisory concept, of these methodologies that are intended to provide the topics for not only the control, because the control, as you know, is the design of an input which makes the plant to behave as you design, but is able so not only to control but also to compensate for the effect of unexpected for example, external sources or effects, so in the more general meaning of the term. And at the same time, it provides, you will see later, I included also some simulations, some also commented, we will see examined, depending on, in the case you are interested, so you can also examine by your own these methodologies that I prepare for this course. And normally these techniques can take into account, it's not the specific aim of this course, but you can include some, for example, constraints. So you are able to include some constraints of on your design, especially in terms of, for example, cost, speed, say computational cost, robustness, reliability, sustainability, and another important now is another important issue is the power consumption, which is motivates also the analysis of the power. So consumption is very important. So we are assuming that you at least from this let's say background, the objectives of the course is to provide some basic techniques for designing a supervisory system which works in the steady state and transient conditions. You will see also some methodologies for the system identification. We will see this important. Task is really one of the methodologies that can be considered for deriving a model of the system. And we will see also some strategies for modeling your system in a nonlinear way, which is, we will see almost after the first half of the course. So the description of the model will be derived using neural networks. Is one of the knowledge that you will acquire. And then we will see as a unified framework the integration of these methodologies in order to obtain this supervisory, let's say, control. So at the end, you should be able to analyze a system, design, let's say, this supervisory system, select also the most suitable system identification algorithm depending on the task you need to solve. And then also the derivation of the most, again, suitable model in order to derive the parameters that are required for the design of the supervisory system. So the course, as you know, is consists of 20 hours. So today we will start from a general introduction to general systems. We will see from the beginning this multidisciplinary technique, which is in this unified framework. And then we will see also some optimization tools that are used for the adaptation, the derivation of these approaches, of these techniques. As we will see, there's some recursive algorithm, and also we will recall some perhaps well-known tools already available during your master course, let's say bachelor or master's courses. And one another important point, which is also some topics, among the topics of the master courses, in the coverage of the neural network approach. So neural network is used for the derivation. Not only is one option to derive the model description, the plant, description, but also the mathematical description of your supervisory system. So it's not limited to, as normally can be proposed, 20 years ago, only to the derivation of the model, as we will see at the beginning. But so it can be able to solve both the tasks. So one is the model, and then to describe also the supervisory system. So in order to enhance your, say, to follow, today we started with an introduction. So today is an introduction, and I feel that this is not updated. So now it's sorry, it was again is the in the memory of the browser. So now is I will include the dates as soon as we examine the specific parts of the course. So today's at least is, let's say, 15-20 minutes is devoted to the presentation, the general presentation of the course. And as you can see here, there are specific topics, we will already mention it. So the first part, let's say from 1 to 4, is oriented to the to system identification, we will see today. And then after I included also a very brief introduction if you want to let's say go deeper into that depends on your course of studies. I put here as a lecture 5 a tutorial, so is an introduction to this toolbox. As you know, if you are not familiar with the MATLAB Simulink, these very powerful tools are divided into different what we call toolboxes. Each toolbox represents a library dedicated to a specific topic. So for each, let's say, item of your research, maybe you can have already developed a library specific which covers, for example, the specific application, or I don't know, the specific physical description of your application for the different areas. For example, the engineer, you have some I don't know, libraries for the telecommunication, to electronics, let's say, to the neural networks, to every specific topic that was developed. In the previous version, you have about 84, let's say, toolboxes, this specific library. So you have really a huge amount of resources that you can think to use for your applications. And then after the lecture 6, we will go into the derivation of a very brief introduction to neural networks. So I decided to explain quite quickly the structure of a neural network. I know that if you want to provide, I don't know, perhaps for undergraduate students, have at least an introduction to neural networks, you need to spend at least 10 or 15 hours. That is something that perhaps is why you can already acquire this knowledge during your master's studies. So it's why I just recall some topics of neural networks, and then I will focus on the application, which is to make quite perhaps more interesting, and then some application examples. So it's why at the end I put some references that can be used, of course, not really for this course, but if you want to have a deeper insight into these topics. And I included also some simulations during here, we will see during the courses, and some examples, application examples. The examination method is something that is organized into quizzes, as here is mentioned here. So I will send you a link with is a Google form. Again is a self-paced, let's say, exam. So it means that you can examine it by your own. You don't need. There is no a limited time, or so you have about 30 multiple choice questions, and you can answer depending on the time and the topic, so you have time also to think about the questions, and to try to give the proper answer. So at the end of the course, I will send you this link and you can answer. So I think we have already completed the description of the course. You have also the dates is from the starting page, which is my page, which contains all the courses that I'm teaching. So you have the schedule here. So the next lecture will be next Thursday, the same time. Normally I try to find free slots in among your courses. So okay, so I think we can close this part.